Okay, part 3. Let's see if we can finish it off. If I reflected this across the x-axis first, it ends up somewhere down here, not this exact thing. And then I reflected it across line L, then it would go way up here. So that's obviously different from this. So the answer is definitely not true. Now, sometimes false or always false. Well, look at this one right here. What if I reflected this across the y-axis first, and I got U right there, and I got Q right here, and etc. D and A, and then I reflected it across line L, would I get this? Well, the answer is yes, I would. So sometimes it's true. And when is it sometimes true? When your axes of symmetry that you reflect across are perpendicular lines. Okay, that's pretty much the only time you're going to be able to do something like that where it is always, where reflections would always be commutative. Otherwise, they're not always commutative. So the answer is sometimes false. The only time it's true is when your axes of symmetry are perpendicular lines. Okay, this one kind of had weird wording as well, depending on how you looked at it. So I have circles Q and W. They're congruent, so that means that they both have the same radius, and I gave you a simple explanation showing this is length R. They intersect at this one point P, so that means they're just touching at that one point, and they're just touching against the ground as well. So they are, how high are they off the ground, if you ever needed to ask? Well, they're R units off the ground, if that clearly mattered for this problem, but we'll soon see that it doesn't really. Okay, we're going to try and do a reflection first. We want to show how I can map this, transform it, so that it would look like it's right there. Okay, let's do it with reflection first. And you had multiple choice, but let me just show you quickly what answer you would want to choose. I asked you to try and do try and draw out all the different locus statements and see what would work. The correct answer would have been this one, the one where you reflect across line L. If line L were placed right here, right? Because I would take Q. In fact, I can probably here. Let me try this. I can probably do an animation and just make it flip. Oh, I don't want to flip there. Let's flip it from the right edge. Whoops, that's not the right edge. Okay, so there you go. So it flips across the right edge just like that. So there's that axis of symmetry, and there's the reflection. Okay, now I don't want any rotation. All right. You've had your fun. Let's bring you back. Okay, so hopefully you got that one. So what's this locus? This is the locus of points that are equidistant from Q and W. Remember, like those perpendicular bisectors, if you had a segment across, W and Q are both equidistant, R units away from P, and you keep going up, all these are equidistant from all those points as well. Okay, so hopefully you got that one. Let's check that one off. Okay, translation. This one could have been the easiest, but you had to say how far it went over. So remember that this is R right here. Let me, I can probably move this over like this. All right. Now this is the length of your radius. So if that's R, how far does Q have to move over this circle? It would have to move over 1 R length, 2 R lengths in the X direction. 1, 2. Right? So it went positive 2 R units in the X direction. So mapping it from X, Y, it went X plus 2R, and Y, you would have to put Y plus 0, or you could have chose not to put anything, right? It didn't move at all up or down. It just moved over that much and that much. R plus R, 2R. So that's as far as this circle moved over. That's translation. And rotation, you had to say how far it rotated about a certain point. So let's figure this out, and I'll give you the answer now. I'll say you had to rotate it about point P, and I'm going to try and simulate a rotation here you get Q about point P, and it rotates around here, and it lands on here. And that's 180 degrees, and it didn't matter clockwise or counterclockwise or whatever, and it went about point P. So P is what it's fixated around. And was that it? Yeah, that was it. So you have to say 180 degrees about point P. Let's check that off. Okay, and finally, last one, number 8. A trapezoid's vertices are listed below in matrix form, only T and R are revealed. Okay, so hopefully you remember that T, in this case, T is -4, 1. Here's its X, here's its Y. And R is -2, 6. So we can go ahead and plot those. -4, 1, here's T. And R is -2, 6. Now you might think, uh-oh, I didn't give you the other 2 points. Well, that's okay. I'll show you them in the reflection. When the trapezoid's reflected across the y-axis, below are its vertices, also listed in matrix form. So I gave you A prime. It's at 0, 6. And P prime is at 0, 1. Here's A prime, here's P prime. Now remember, I reflected across this axis. So think about where everything would be. Where would A be? Well, A would still be exactly where A prime is if it was reflected. Where would P be? P would be exactly where it is. Now T and R would be in a different place though. I reflect this across the y-axis, where would I go? 1, 2, 3, 4. 1, 2, 3, 4. Here's T prime. And R, 1, 2, 1, 2. Here's R prime. So together, this pre-image and this image make this shape, which is a trapezoid. So what is the area of the trapezoid formed by both of these? So you have to remember that the area of a trapezoid, let me scroll down just a little bit here. It's 1/2 your bases, the sum of your bases times your height. So let's go ahead and count this off before time runs out here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So there are my 2 bases, 8 plus 4. And here's my height, going from 1 to 1, 2, 3, 4, 5. 5 is my height. So let's plug those in. 8 plus 4 times 5. So that's 1/2 12 times 5. 1/2 times 60 is 30. 30 square units if you leave those answers as well. Okay, so the important thing there to note is that here was my pre-image. Here was my transformed image. Even though I didn't give you all the information, by the transformation, you could potentially know all of it there. Okay, and if there are any other questions, please let me know. I think that's it. Yep, that's it. And I will sign off right there.